Hello everyone, and welcome back to this tutorial section. Here we will talk about the numerical simulation of a lifeboat. This case is built in STAR-CCM+, and it is a two-phase flow example. We want to simulate a lifeboat entering the water surface. For its motion, we will use the overset mesh method. This example is one of the official STAR-CCM Plus benchmarks. You can also find its description in the user guide. We will go through this tutorial step by step. I will explain what happens in each part and what to set. I will also show how to complete the tutorial correctly. Let us start with the main description given for this example. As I said, this is a solid body, called a lifeboat, entering water. The air-water interface breaks during the entry process. The lifeboat motion is controlled through the overset approach. The main properties of this case are listed here. The body mass is 10,000 kilograms. Now let us look at the inertia values. The inertia about the center of mass is also specified. The moment of inertia around the center is 16,000. The initial downward velocity is 22 meters per second. There is no angular velocity, so that value is 0. Its initial fall angle is 35.5 degrees in this setup. Now we will set up this case in STAR-CCM Plus and start solving it. In this example, you will learn the overall setup workflow. First, we import the mesh into STAR-CCM Plus and set the regions. Then we define the boundary conditions and the two-phase physics. That includes both the air continuum and the water continuum. Next, we connect the regions by creating the required interfaces. Then we generate the mesh needed for each section or region. We will also show how to move the initial overset region. We place it at the required coordinates and height in the domain. Next, we apply the Eulerian phase models for air and water. Then we move into rigid body motion and explain the setup. We will model and solve the lifeboat motion in the reference frame. After that, we set the wave and free surface settings. This defines the interface shape that we want to use. Next, we apply the initial conditions for the solver. That gives the case the correct starting state for the run. Then we set the boundary conditions and the solution controls. That includes the stopping criteria and where the run should stop. We also create scenes so we can monitor the simulation. Then we initialize the case and watch how it progresses. We run the solution and finally review the results. For now, I recommend using the guide beside this video. I will try to provide that guide with this training set. That way, besides watching the video, you can also study the guide. You can read the tutorial step by step and follow it more carefully. That will give you a better understanding of what happens next. It will also clarify the extra notes in this training. Let us start part 2.